In this video tutorial, we will create the following simple calculator app in Flutter. We can compute some of the basic addition, subtraction, multiplication, and division problem, and we can also change the orientation of our app so we can provide it with different layout. For example, if I make it landscape mode, I can see that I have a different layout, and the value from the portrait mode was transferred as is and not changed or interrupted. To do this, we will look into how to use the row widget, the column widget, expanded widget, the MediaQuery widget, so that we can be able to handle orientation and so on. So first, let's close this project and create a new project. And I will open a new folder in my desktop, and I will create a new folder. I will call it calculator, rename it selected, and I will create I'll open a new terminal and create a new project inside this folder. I'll call it calc, and I'm gonna go to the main.dart file, and I will remove all the comments. For this, I will use my own Visual Studio extension that I created to remove comments. You can try it if you want. It's called Remove Flutter. This one, you can download this one. Then to use it, all you have to do is just go to the View menu and select the command palette and type FRM, and this will remove all the comments from the default project. And now let's run it without debugging. You need to first open an emulator. For that, just click on here at the bottom. If it says no device, just click on that and select your emulator and run it. So I'm gonna run it by going to Run menu and run without debugging. Let's wait for it. So this is the default project that we created. So it runs. So now let's create our calculator. So the first thing that we need to do is to change the title to simple calculator. Then we can also make or give the home page to take the title calculator. So this is what's going to be displayed in the scaffold. I'm going to change the name of the my home page to calculator. And let's copy this, rename my homepage, and this as well. I'm going to make it calculator state, copy this, rename it, make this calculator, not calculator state. And now we have everything here. I'm going to clear out this section. I don't need this section, starting from center. And I don't need the floating widget. And I will change the theme to be blue. And in case if the user want to switch to dark theme, I can add the dark theme here. And I will use theme data. And now let's remove this. We don't need this part. I will need a private field, and that's going to be a string. This string will hold anything that we type or that we see on the calculator display. So it will be stored in this string. The reason why I have it in here is because in case we have to deal with orientation, whenever we change to a different layout, the data will be transferred from this property to the new layout. So we'll see that. So the first thing that I'm going to do is I'm going to handle the orientation change. For that, we need to use the MediaQuery widget. I'm going to call it final. Let me call it media, and then I'm going to use the MediaQuery of the current context. And I'm getting an error here. I think it's because I'm using the underscore here. I'm going to save that, and the next error is going to be at line 33. Okay, so I'm missing one bracket here. I needed a semicolon here. So in my body named parameter for scaffold, I will provide it with a condition where the MediaQuery is going to check whether my orientation is on landscape mode or portrait mode. Actually, I can change the entire widget to be a stateful widget, so I can check it from here. Let me delete the entire scaffold widget in here, and I'm gonna return. Here I'll have an if condition to use the MediaQuery and check the orientation. If the orientation is landscape mode, then what we return landscape mode widget, or else we return a portrait mode widget. So for that, we will need to create a Dart file here. So I need to organize it. Let me create a folder here, a new folder, and I'll call it a widget. Then inside here, I'll create two files. First one's going to be calculator landscape.dart. It has to be a small letter. And the next one's going to be portrait mode.dart. So let's go to the first. Let's design these two widgets. The first one we're going to design is the landscape portrait mode. So open this file, and we will create a stateful widget, and we will call it calculator, or we can say calculate portrait. So I'm going to import the material widget, material.dart. Then we need to take the title, so final string. I'm going to have two final fields or properties in here, string str and final string title. This one will go on the scaffold widget, and the first one is the value that is stored when the user is actually playing with the buttons, or anything that is shown in the screen is stored inside this variable or field. Then in order to pass it to our stateful state widget, we need to create or we need to assign it, or we need to provide it with the a constructor that takes in two parameters. First, I need to assign it to a value using a constructor. So calculator portrait mode. Then I'm going to use named constructor. Key is going to be key, and this is going to be a required field or name parameter. So I'm going to be title. It's going to be title, and this is also a required parameter. It's going to be this dot string. Then I'm going to assign a super with key. Then my state widget is going to take this to only the string value, so that it can update its stateful property or state property. So it will be a constructor that takes in a string. So here I'm going to create a constructor of stateful constructor that is taking a string and assign it a value. So this constructor, this state widget will have its own variable or field, private field, str. So this means that the value from here will be passed to this constructor, so a title, and then this value will be passed to the stateful widget. Then this value will be assigned to this private field inside the state widget, so that in case, for example, we were in a portrait mode, we made a calculation, let's say 2 times 3, then we change the orientation to landscape mode. If that value, in order for that value to be transferred to to be displayed in the landscape mode, we need that value stored somewhere that is not going to change, which is in this string. So whenever we switch to a portrait mode or landscape mode, the design will change because we are calling a new class called class landscape. Then when we call that class, we will pass that value to that class so that it can keep the value in the screen as it is and not display a different value. So that's the reason why I have modified the constructors in here, so that I can keep the same value whether I change orientation or not. So we will see how this is going to work. So now the next thing that we need to do is let's put a semicolon here. We need to design our layout. So we said we need a scaffold, and the scaffold widget will take an up bar, and the up bar is going to take a title. We'll take the widget, that title from here. So this has to be inside a text widget. Then next thing we need to do is the body. The body will take a column, one single column, and this column will have children. But before that, I want to change its alignment to cross-axis alignment, and the cross-axis alignment will be stretched, and we will use so if we look at this picture here from our calculator app, we know that we have a column that is holding the entire screen. Then we have a container to display the values. Then we have multiple row widgets containing the calculator button. So 1, 2, 3, 4, 5. So we have 4 row widgets. Then inside them we have different buttons. So in total we will have 1, 2, 3, 4, 5, 6 rows. So we will do that now. Inside this widget, the first one will be the screen. So that's going to be inside an expanded widget. The reason why I'm using expanded widget is because expanded widget will, as you can see in the documentation, it will expand the child widget so that if it can fill the available space. And so I can use a name parameter called flex so that I can adjust the width and height of this row widget based on this flex value. So let's do that. For example, I'm going to have a child of container here. Container is going to have a child of padding. Padding is going to be edge from left to right. I'm going to make it 15 by 15 by 15 by 30. So, and the child is going to be, for this padding, is a text. And that text value is string, str underscore str. So that's what we're going to show inside that container. So I'm going to give it an alignment also. So I want it to be on the bottom right side of the screen. So alignment. So let me save it. Let's restart it again. Oh, as you can see, we have an error. So that is because I'm not displaying. So if you go to the main file, I'm not returning any widget. So I want to return the portrait mode, the portrait widget. So I'm going to do calculate portrait. So I will provide it with the title. So the first name parameter is what? Key. So I'm going to take the widget dot key, then the title, widget dot title. So this is coming from here. The key is coming from here. And the last one is the string, which is this value, this dot. And over here, for now, let's put a container here and save it. As you can see, we have an error, line 30. Let's restart it. So we displayed our container because this is not landscape mode. This is portrait mode. So I'm going to cut this out and put it over here and make this container for now. And let's run it. So again, we have an error. So that error is coming from here because the string value is null. So I'm going to use the init state to initialize the string for now to 0. Save it and let's look at it again. Let's restart it. As you can see, we have our string down here, the bottom right corner of our screen, and expanding to the entire body of the app. So let's fix that. First, I'm going to keep the string as style. So text scale factor to be what? 3.0. Style to be font size 20. Alignment, we said it's going to be to the right. Can save this, and if we look at our app, you can see now the size is increased. Now let's add the other rows which contain the different buttons. So I'm gonna put them inside an expanded widget again, and we need to provide a flex value for our display. I'm gonna make it flex value of 2, and I'm gonna make the flex value for the other widgets to be 1. So I need multiple expanded widgets here. Let me bring the picture here. So that's the display, which is this one. That's the display. And now I need 1, 2, 3, 4, 5 rows with the same flex value. So I already have 1, so I need 4 more. I'm gonna copy this. I'm gonna paste it 4 times. I'm gonna save it. And I'm gonna look at the screen. Let me refresh. So we need to provide it with the child widget. So our child widget is going to be a row. I'm going to copy this, save it, and let's look at it. As you can see, we have now changed the layout for our screen to be flex size of 2, and the rest of the screen size is occupied by this expanded widget. So now I'm going to create the buttons. For example, let's create the first 2 buttons, which is this area. So as you can see, this area, I only have 2 buttons here. So I'm going to come here and child widget, and this child widget will take 2 children, actually, not child widget, of again expanded widget, and they will have a flex value. Let me put a comma here. Flex, let's make it what? In this case, since the button is larger than the second one, it will take a different flex value. Let's say 9. That means that it will take almost 80% of the row area, and then the rest will be occupied by the other widget. So I'm going to give it a flex value 9, and this will be a child of a container, and this container will have a padding of all sides to have 0.5, and this container child will be a flat button, and the child for that flat button is a text, and the value for that text is going to be, the first button is what, C, cancel, and I'm going to give it a style, text style, color, give it a color of black, and font size of 20, 30 or 28, and we're going to have an onPressed function, and there's nothing for now, and the color background for this button is going to be gray. And let's look at it. As you can see, it is fully expanded and then took over the entire row widget. But if I add another expanded widget here, copy this whole thing, and after the first expanded widget, I'll add this one, and this one is going to be delete, and the flex value is going to be 3. And if we save this, so you see that there's another button here. Since I'm going to copy paste this widget repeatedly, the best way to handle this is by creating a separate custom widget over here. So I'm going to create under widget folder, I'm going to create a new file called custom button.dart, and I'll create stateless widget. I'm going to call it custom button, and I need to import material.dart. Then I'm going to return an expanded widget. So I'm going to copy this, I'm going to take it here, delete the container widget, and return the expanded widget, and format the layout. This has to be a semicolon, format it. And since we are going to use this, or we're going to make this a reusable code, we need to provide it with a constructor. But first, we need to have some properties. First one is going to be final string, going to be a value. That is a value for the string. Then final function. Our function is going to go here. For when we press, we're going to call this function func. Then final int value flex value, and final color, background color. Then I'm going to create a constructor so I can initialize this values. Custom button, this dot value, this dot function, this dot flex value, and then this dot background. Now I can change this values to dot flex value, and this one is going to be this dot value, and this is going to change to this dot function, and this one is going to change to color, it's dot color. Now I can use this custom button. I can go back to my calculator app. I'm going to delete this, and inside here I'm going to provide it with a children actually. First is going to be a row child, and this will take a children's of custom button, and this custom button will be the value C, the function, for now it's empty, and the flex value is going to be 9 for the first one, and the color I'm going to use the black 12, and I'm going to copy this, paste it, change the value to 3, flex value, and the name to be delete. Save it. So the color changed here, and I want to give it a cross-axis alignment, stretch. Now it's a little bigger, and I'm going to copy this to, I'm going to copy the whole thing here, the whole row widget, and I'm going to add it. I need a flex value for this one, 1. Paste it here. So now I'm going to have 4 buttons, as you can see here in the picture, 4 buttons here. So I need to copy this and paste it one more time, and change the value to 7, this one to be 8, this one to be 9, and this to be a plus sign. And we have a flex value for this one. Cross axis alignment for the row widget is going to be 1. The flex value for this one is for the column widget, whereas the flex value for this one is for the row widget, which is this value. But in this case, since they have the same size, I'm going to make them 3 for all buttons. And I'm going to copy this again. I'm going to delete the whole thing in here, and I'm going to paste it 3 times. 1, 2, 3. If I save it, now the whole thing is filled. All I have to do is just change the values. So first one going to be the third row. That will be 4, 5, 6, and the minus sign. And the next one is going to be 1, 2, 3, and the multiplication sign. And the last one is going to be the last row, 0 dot equal sign and division. If I save it, you will see the layout is done. So now I can copy the whole thing in here, and I'll go to the landscape mode, paste it here as well, save it. In the landscape mode, that's the picture. We have 1, 2, 3, 4 rows. In this case, we have 1, 2, 3, 4, 5, 6 rows, but the number of columns increased in this case. So what I'm going to do is adjust each row, and I'm going to change the flex value for some of the row widgets. So let's start with the top row, which is the one that is holding the screen, and we will adjust the flex value to 1. No, actually we can keep it as it is, and we can come here again. We can keep the row flex value as it is, but the column flex value as it is, but we will adjust the row flex value and remove one column from the landscape mode layout. So let's go to the second column, which is this one, and we will add the cancel, delete, and dot button in here. So what we're going to do is copy this and add it below 9. Then we can bring the dot button from here, cut it from here, add it over here, and we will take the plus button, cut it from here, which is the second row, and take it to the third row after the number 6. We can also add the multiplication button and add it to the second row after the minus button. And we will take the last row values, cut it from the last row, and add it to the third row or third column, and we can delete this one. Now if we save it and run it, we will still see the landscape mode, but if I switch to we will still see the portrait mode, but if I switch to landscape mode, nothing changed, because if I go to the main file and check the landscape widget, it is actually landscape. I'm going to copy this and paste it over here and change the name to calculate landscape. I haven't changed the name here, still portrait mode. So I've changed the name for the landscape widget to landscape. Copy this, and I'm going to change this one as well. Calculate landscape state. Copy it. Now save it, go back to the main function, calculate landscape mode. Now save it and run it. As you can see, we have a little problem here. We have an extra widget at the top, so I'm going to go back to the landscape widget, and I need to delete this row. Save it again. Now everything is fixed, but the flex value is not adjusted. So adjust the flex value, save it. Now I have created the layout for both the landscape mode and the portrait mode widget. The next step is to handle the computation. To handle the computation, we will create a separate class. So I'm going to create a new file inside the lib folder, and I'm going to call it calculate.dart. And this compute class, will be a static class. So it will be a static. We'll have a static field string str, and the value is going to be 0. So what I'm going to do is I'm going to go to the main file, and here I assign the value 0, but now I want to use the value from the compute class. So what I'm going to do is just use the compute.str, and I need to import that class. So now anytime a computation is done, the value comes this string. So if I update this string, I'm going to see the most updated value in my calculator. So the next thing that we need to do is to handle the input. So for that, I'll create a simple function called add. So this function will take a string value, and if the string field over here is 0, it doesn't have any value, then we assign it to value. But if it is not 0, we concatenate that value to the string. So if I come here, my portrait mode class, where, for example, I have the number 7 here. What I'm going to do is I'm going to create a private method over here called update that will take a string value, and it will call the compute static class add function and give it the value val. Then it will set a state so that it can update the UI, this dot string, which is this string, to be updated by the compute dot str value. So what this set state is going to do is anytime I press the number button, it will call the compute method and it will add it to this string. Then it will update the screen to this value. So the screen value comes from this field, as you can see over here. So now, for example, let me save this and let me use the update function on all the buttons. So what I'm going to do here is update with the value 7 semicolon underscore update. So I'm going to copy this. I'm going to put to all the numbers, the plus sign, 0, the dot, the division, but not the equal sign. The equal sign eventually is going to compute, so I'll leave it as it is. But now I'm going to change the value to 0. It's going to be dot. This is going to be division. It's going to be 1. It's going to be 2. It's going to be 3. And this one is going to be multiplication. And this one is going to be minus. It's going to be 6, 5. This one is 4. This one is plus. This is 7. This is 8. And this one is 9. Save it, run it, and we will go to our emulator. Since we only updated the portrait mode, so we will switch to portrait mode. Now if I press 7, the screen is updated. 8 minus 6 times 3, and so on, divided by 2.1, and so on. Cancel and delete is not working yet, so we will fix that now. So the first thing that we need to do is to clear the screen. We go to the calculate class, and let's create a static function, void, called clear, and I will change the value of the string to 0. And to delete, clear is clearing the screen, delete is different. It will delete the most right digit of the string. So static void delete. So if first we need to check if the string is 0 or not. If it is 0, we don't need to clear anything. Only time we're going to clear is, or delete, is if it is not 0. If it is not 0, what we're going to do is we will create a temporary string, then the substring from 0 to str minus length, str.length minus 1 will be stored in this string. That means the last character will be ignored, but the rest of the character will be stored in this temporary string. So what we're going to do is we will take that temporary string and check if it is null again. If it is null, we will do str equals 0. If it is not, we will do str equals temp. Now we can fix the value for, go to the calculate portrait widget, and we will create two functions, private functions. I'm going to call them void clear set state. So we need to call the compute dot clear. Then we set the state of the string to be compute dot str, and I'll create another void function, delete. Then we call the compute dot delete, then set state this dot str to be compute dot str. Save that. Then we can come up here. So delete is going to call, clear is going to call clear, delete is going to call delete. Now if I go to my emulator, this will change to 0. So now if I have the number 895, if I want to delete, it will delete the last number. And if I want to clear, the whole thing is going to be deleted. The next thing I need to do is to compute any arithmetic computation down on the calculator. For example, if I do 89 plus 6 and if I press equal, the value will be computed and the new value will be displayed on the screen. To do that, I need a compute function inside my calculator static class. But before that, I want to use the init state function in the calculate portrait mode and then the calculate landscape mode widgets. The reason I want to do that is anytime I call these two widgets, the value so that the value can be updated from the main string field. So let's see that. First, I'll come here, I'll do init, just going to override the init function or a stateful widget. Then I'm going to set the state to be the value from the calculate class. So I want the state to be the state of my string to be assigned from the calculate class. So I'm going to come to my portrait mode. So this underscore str, so this string will get the value from the compute.str, and we know that the value of this string is coming from compute.str. So for example, I'm in portrait mode and my value is compute.str. Let's do I make a computation, and if I change my orientation to landscape mode, what's going to happen is in my main function the orientation will change when this build function is called. Then it will go straight here and it will assign the fields with the name parameter, widget key, title, and the string that is coming from the compute class that is not touched, so that I can continue the value that I had from my portrait layout pass to the landscape layout. So we can do that we can pass the values by using this init state function. So I have init state in here. I also need to have an init state in my landscape mode, but I also need this all these functions. Let me copy all this function from my portrait mode, copy them, go to my landscape mode, and paste it here. There's no difference. All I need to do is import this class, and that's it. Save it. So now if I rerun this will turn to 0. But if I have a value 56, delete, let's say 56, and if I change my orientation, that 56 will be passed to the portrait mode layout. For example, let's say I don't have that init function in here. Let me comment this out. Save this, and let me switch orientation to, I comment out the init state function from the landscape widget. Then I'm going to go back to my emulator and change the orientation to portrait mode. Then let's rerun it. Now the value is 0. I'm going to put here 4555. Now if I change the orientation, the value will disappear because it's not updated. Only way we can update it is by using this init state function. And let me update the clear button with clear, and delete, and put the update function over here with the value 7. Save it, semicolon. Let me copy this, provide it to all the buttons except the equal sign or the equal button. Save that. Now we can create our compute function to compute the result in case, for example, say if I have 69, and let me run it again. If I have like 55 minus 6, and if I press equal sign or the equal button, it will compute the value and then display the new result. To do that, we need to have a compute function here that returns a string, static compute function that returns a string, and it will work on the static string field str. So first what I'm going to do is I'm going to split the input to list of strings. So I need a list temporary variable of strings, lst. So that list is for now, it's going to be empty. Then I need a for loop 0, and it will loop up to the length of the string. Then I will need to have a condition here, if condition, and it will start from the string I position and compare if the position of that string index position is a plus sign. If it is, it will store or add any value before this index position to the list, str.substring from. So I need another variable to update the index position. So let's say int start. At the start of the for loop, the index position is 0. So I'm gonna take from the start position to I to be added to the list, and also that index position lst dot add stri. So this means that, for example, I have 44 plus 55. So what I'm going to do is I will read the index position 0, 1. It's still not plus sign. Now we hit the plus, the index position that contain the plus sign. So what we're going to do is we will take this substring and store it to the list, and also store this index position or index value to this list. So now our list is going to contain 4, 4, and plus. Then we're going to update the start position to I plus 1. So that means this plus to the next position. So if I have 4, 4, 3, 3 plus 5, 5, 4, 4, if I am in here, my next starting position is going to be here. So we'll do this for the minus sign. So I'm going to copy this, and I'm going to do else, and paste, and change this to minus, and I'm going to do else multiplication, and I'm going to do else division. And the last thing that we need to do is check if the string length or the starting position is less than the string length. That is, if we didn't find any minus or plus or multiplication or division characters, we will check the string length, whether it's less than or not. If it is less than the starting position is less than the string length, what we're going to do is we will add it to the list. So this means that we checked our str and we didn't find any other arithmetic expressions. So that means what we are left with is a number. So add all of them to the list, or add the substring from that start position to the end of the string to the list. Where that means that, for example, if I have the number 444, and if I run compute, there's no arithmetic operation, so this will be added to the list using this code. So that's going to do str substring from start to str.length. So once we have our string is split to a list based on the arithmetic operation delimiters, we will start computing or doing our operation or computation. So we will have another for loop, for int I from 0 up to I less than list.length. Now we're going to operate on the list I++. Then if I equals to 0, that means we don't have any arithmetic operation. So we will have a new variable called result. So that is double result. For now, let's give it the value 0, and our result will be double dot parse that string to lst.i. So that is if index position is equal to 0, else if index position is bigger than 0, and double dot check if it is that index position is not null. So by using the try parse, we try to parse list position I, and if it is not null, then what we're going to do is result, we will have an if condition and check that list previous value, and check if it is an arithmetic expression or not. For example, if it is a multiplication, then we do a multiplication by using result equals double dot parse and our current index, our current list position. So to recap, if we are at index position 0, all we have to do is just parse it and assign it to the result variable. If we're not at the index position 0, we will go and check if we are an index position that contains a value and the index position is bigger than 0. Then what we're going to do is check the previous index position, check if it is a multiplication. If it is a multiplication, do a multiplication computation. If it is not, we will copy this, else if, paste it, check if it is a division. If it is not a division, we will have an else if again, paste it, check if it is an addition. So if it is a division, we do division over here. If it is an addition, we do an addition over here. And lastly, else if it is a subtraction, check if it is a subtraction and we subtract. Else if it is a different character that is inserted, we will display or return an error string, or else we will come out of this if condition and the for loop, then we will return a string of the value that is computed. The value that is computed is result. Since result is a string, we have to change. Since result is a double, we need to change it to a string. So that means we need to return a result that to string. So that has to be inside the function. So we can save this. Now we can go to our portrait mode, and over here we can call the compute function. So let's create a private compute function first. If compute, we need to check if the string is null or not, because if it is null, we're going to get an error. If it is 0, we don't need to compute anything. Otherwise, we need to set the state this dot str to compute dot compute. Did I call it computer? Yes. Then we also need to update the compute static variable compute dot str to this dot str, and now we can go down at the button equal. We can call compute. Save this. We can also copy this code duplication, but for now it's fine. Paste it over here, and we can go down the equal button, call compute. Then save this, come up here, run it. Seems that we have a problem. Calculate, save that, run it. Now let's do an addition. 89 plus 6, 95, or time 6, 570. Or if you don't want to see the decimal point that is 0, we can fix this at the compute function. So let's go to calculate, and over here check if the decimal value is 0 or not. To do that, we can, before we convert it to a string, let's result minus result dot truncate. So this function, the result dot truncate function, will give us the decimal point, the decimal values only. And what we're going to do is check if it is 0 or not. If it is 0, then we return result dot truncated value. But if it is not 0, we just return just a string. Save this, run it. So now let's say 5 times 6. Now we don't have any decimal point. But if I add a decimal point times 6, I have a decimal value. Or minus 6, or I can clear this. 6 minus 7, I get a negative value too. Clear this. 9, 5 plus times 3 minus, I get that result. We can also add this function to our landscape mode. So we already added that function, so we can check it now. Let's go to landscape mode and let's multiply. I don't think we updated the value here. We still have 7, so let's make this one 8, this one 9, this one dot, and this one to be 4, 5, 6. It's going to be plus, minus, multiplication, and this one is going to be 1, 2, 3, 0, and division. Save this, restart, go back portrait mode, then do some calculation here. Times 6 plus 5 minus 4. Then let's change the orientation to landscape mode. Now times 9 plus 3 minus, we get that result. So this is our simple calculator app created using Flutter.